Good morning, everyone. Thanks for being here bright and early at 8:30 on a Friday. I'd like to give you all a round of applause for being great System Center fans. I know it's tough to be here on the last day of the show so early, so thanks for showing up. I'm here with Amit Vermani. I'm Greg Kazanza. Amit is the senior test lead for the Fabric portions of VMM, and I'm a program manager on the VMM team. So we're here to talk about zero to cluster to cloud today. What we're going to do in this next hour is we're going to start with bare metal. We're going to deploy an OS, create clusters, a highly available cluster. We're going to create a cloud from the cluster, and then self-service user role, deploy a service to show that it actually works. All within an hour, you're going to go from zero to actually having a highly available cloud. You'll be able to go home and do this yourself if you have the machines, so it's going to be an exciting hour. So let's get started. I've got a lot of demos today. As part of these demos and slides, we're going to go through and we're going to show you how to use these raw resources to create private clouds from them. There are a lot of steps along the way as far as allocating the resources, how you add the abstractions on top of it that I'll be talking about. And eventually, we'll create the clouds. And then I'm going to share a lot of tips and tricks. We've been working on this for over 2 years now, and we've learned a number of things along the way, so I'm going to do my best to share those with you as we go along. So what are we going to do? How do we go about creating this private cloud starting from essentially nothing? Well, you do start with something. You start with your diverse infrastructure. You start with a variety of compute hardware, a variety of storage hardware. It can be from different vendors, it can be from different manufacturers, different versions. But one of the things that we've learned, we talked with our own internal data centers at Microsoft, and we figured out, so what do you do to make this diverse infrastructure work well together? And the first thing they told us is consistency. For our own data centers, they generally start with one consistent set of hardware. The same machines, they buy them by the rack or by the crate even, and they buy the exact same machines over and over again, because they want to get that consistency. They then put a consistent software layer on top of that, a consistent image-based deployment of the actual OS that runs on top of those machines, so that every single compute node in your environment or in their environment is exactly the same. So that way there's no variation among them. If something fails along the way, they don't try to fix it, they don't try to troubleshoot it, they just redeploy the image. If that doesn't solve the problem, then they just disable the node and at some point replace the hardware. But how does that work for you? Because you don't have the consistency of the hardware. You buy hardware in chunks. From talking with our customer, we learned that you don't always have the same exact machines, the same storage. So what we do is we start to layer concepts on top of it, where we layer a host profile that gives you a consistent OS layer across your diverse hardware, and that gives you a consistent OS image on top. Once you have a consistent OS image, then you can start to act consistently at the software layer above your inconsistent hardware. So we do our best to give you a consistent OS. We also have steps along the way that let you bring your firmware up to a consistent layer within your hardware as well. Once we have a consistent layer across your fabric, then we can start to build a cloud abstraction. This is the next layer of logical abstractions that we can build on top of your fabric. The key point of the cloud is that, number one, it's elastic. That's, with your compute, your network, and your storage. All of you should be aware of that's one of the key properties of a cloud. But it also makes an opaque layer that separates your self-service users from the fabric underneath. So they don't know what hardware you have, whether it's the same brand, different versions. They don't know what storage you have. They don't know what compute you have. They just see the aggregate of the resources that you have available in that cloud. That's one of the keys of the cloud abstraction. So once you have this abstraction, you have this layer between the hardware and the users. You can now start to create your self-service users and assign resources from this cloud. You actually carve it up and give portions of the cloud to individual user roles. We'll show you all that in a little bit. And then finally, once users have access, they need to be able to do something on it. And so that's where we have this concept of standardized services. So we're going to go through all this in the next hour roughly. And I'm going to show you all these steps. There are a number of sessions that will actually still be taking place today that I encourage you to go to if you want a deeper understanding of some of the concepts such as networking, storage, service deployment. We go into great detail on these in some of the later sessions today. And if you miss them, go back and watch them online afterward. All right, so let's get started. We've got to kick off this demo right away because the longest step of the process is the bare metal deployment of the OS. So that takes about 45 minutes. So I'm going to get that going first off. And then I'll explain what I'm doing, or what I did to get this started afterward. So we're starting with an empty host group. This is basically where we'll be deploying our resources to. We're going to create a cloud out of that. First thing I'm going to do is I'm going to go to Add Resources and select Hyper-V Hosts and Clusters. Because this is going to be, we do bare metal deployment of Hyper-V only. I'm going to select Physical Computer to be provisioned as a VM host. And the first step of the process is we have to actually discover what bare metal hardware you have out there. We do this through a number of standard interfaces. We support IPMI 1.5 and 2.0. This is probably the most common standard that's out there. It's on just about every piece of hardware that we've tested in our labs. So if you have ILO from HP, if you have Dell with DRAC, select IPMI. It's generally your safest bet along the way. One thing, though, that you may have to do, it's not always enabled by default, so you might have to go into the firmware and turn on IPMI in order to use that. We also support Smash as another standard protocol. We feel that Smash is great because it gives us a richer set of information. This is supported by Dell today. We are expecting other vendors to also build in Smash support over WSMAN in the future. And then we also have an extensible interface as well. Here we have a sample Contoso computer extensible interface. So if we ever do run into a hardware that doesn't support one of these standard protocols, that vendor can build an additional provider as well. So in order to discover the machine and talk to it, we have to have a set of credentials. So my first tip of the day is don't name your run as accounts HP BMC and BMC HP. If you want to know which one is which, make them unique. I know that BMC HP is the one that has our correct credentials. So I've selected my credentials. I've pre-created those. You can create them in that wizard if you haven't done it already. I'm going to go on to the next step. And this is where I'm actually going to discover the computers. We have a number of methods. If you know exactly which IP address the BMC is on, you can go and query that right away. If you don't know, if you just know which subnet is used, generally in data centers, all of the out-of-band management controllers are on a single subnet. You can go and query the entire subnet. It takes a little while. We do them in batches of 10 IP addresses at a time. So if it's a large subnet, it'll take a little while to go out and discover that entire subnet. Or you can do a range. This is the most common option. So if I do like 227, 10, if I do this range, it's going to go out. And it's going to go out and go through in every address in that range. It's going to go out and query it. You can see we're searching right now. And it's going to use those credentials, try to log in to that BMC. And that baseboard management computer, that BMC, it's like a person sitting next to the computer that will respond to you and say, yes, I'm here, or there are a number of other functions that it'll do for you. You can use it to turn the computer on, turn the computer off, query the power state. So it's like a person sitting there that you can call up and ask things about that computer. So you can see we found a number of machines available. We'll also return whatever information we find out about that machine so you can uniquely identify it, such as the serial number. The key piece of information that VMM needs is this SMBIOS GUID. This is the unique identifier that gets returned when we query through one of the standard interfaces. It also gets sent when the PXE boot request happens. That'll happen in a little bit. So I'm going to select this machine because I know this is the one that I want to deploy to. And I'm going to click Next. I'm going to put this machine into my 02 cloud demo host group that I've created already. And I'm going to select the host profile. Now, I'm going to show you what's in this host profile in a minute and how to create one. But this is essentially the recipe for how to deploy this OS consistently. If you remember at the beginning, I mentioned we want to make a consistent layer on top of this diverse hardware. So this is the first step of that process, is applying your host profile. And then finally, there is some customization that's unique for every machine. And that's what we have to enter now. So things like the machine name. We're telling it to skip an Active Directory check. We have a number of safety checks to make sure you don't accidentally redeploy over an existing machine. So I know that this machine, though, doesn't exist yet. Next, I need the MAC address in the machine. And the purpose of this is we have to be able to identify which adapter in the machine we can actually set our network addresses on to use for management. If you're well aware with Windows Server 2008 R2, the name that the OS gives the network adapter can vary depending on the order that the devices get enumerated. Now we know that people don't like entering the MAC address here. It's, people don't have generally a photographic memory and don't memorize MAC addresses. So we've done some steps that I'll talk about later to ease this process in our Service Pack 1 release. Next thing is telling it how to configure that management address. It's important that we have the management adapter that is the one that we'll use to finish the configuration after the OS gets deployed. So we have to give it an IP address. So I'm going to do that now. So this is the IP address that we're going to give to the network adapter in the machine that matches this MAC address. We're going to hit next, finish, and now this machine is going through the bare metal deployment process. I'll talk about what all the steps are in a minute, because there's a lot that happens behind the scenes. Along the way, the first thing it's going to do is it's going to do a PXE boot so that it gets the request going into our WDS server. While that's starting, it takes a minute for it to show up in our UI. Let me tell you a little bit about what we've done in advance here, because there are a few steps that we did before I started this demo. First thing I did when I set up the environment is I added a PXE server. So we have to, in order to deploy the OS, we have to have a way to get a boot image onto that machine that has our agent that talks back and forth with the VMM server. In order to do that, we have to have a PXE server. We support the PXE server that is in the WDS server role in Windows Server. And so you have to add a server with that role enabled to the machine. When you add that server, there are a number of steps that I'll talk about in a minute that goes through to configure that. Another thing that I've done in advance is I've configured my logical networks on this, in this environment. I've created a cluster network for my management addresses. So this has the addresses that will get assigned to the management adapter on the machine. And then I've also added storage. Amit's going to talk about storage in a little bit and tell you, what we use the storage for as well. Also in my library, I've added a library server. And within the library server, I've added drivers. So one of the things that we do is in order to take your OS image and customize it for your diverse hardware is we let you put the drivers for that hardware in our library. And by doing that, we can actually copy the drivers that are specific to your machine at deployment time into the OS image so that as we deploy the VHD, we'll inject the drivers. And so you can have a single VHD image for your OS that then gets customized to be specific to the hardware that you're deploying to. And then I just mentioned that you do have the OS on a VHD. That's one key aspect of how we do our deployment. We set up the machine to do the native boot from VHD so that instead of actually, once we format the disk, copying individual files out for the operating system, we just copy a single VHD file out. This is your golden image. You prepare it in the same way you prepare your VHD for a virtual machine. You put it in the VMM library. We then copy that image that you can maintain offline, and we copy it to the host, and then we set that VHD up to boot so that we actually boot from the VHD file itself. So it's great for servicing before you actually do your deployment to create the VHD. And then after the fact, if you need to make changes over time and you revise that VHD, it's very easy for us to copy a new VHD out when you want to do a redeployment. OK, so that's a little bit of what I know. Oh, so now how do you use all these together? Well, I mentioned the host profile is what we use for the OS deployment. Here's the one that I use. I'm going to create a new one to show you all the steps that you go through to create this host profile. So I'm going to go to the Create Host Profile. So I mentioned earlier, the host profile is your recipe for how we're going to configure this machine as we deploy it. I'm going to give it a name. I'm going to call it TechEd demo so I know what it's for. Generally, you'll create one host profile per cluster because that's what your settings are consistent with. Depending on how you want to reuse it, you can go beyond a cluster. But the other good thing about it is once you have this recipe defined, you can reuse it over and over again. So you create your cluster with 4 nodes today. 6 months from now, you want to add 2 nodes to the cluster. You have the recipe for how you originally created that cluster in the VMM server the whole time. So I'm going to select the VHD that I want to use for this profile. It's a standard Windows Server 2008 R2 Service Pack 1 VHD. We tell you information about the size of the VHD. We support deploying dynamic disks, although in production we generally recommend that you use fixed disks for production. When you deploy a dynamic disk, what the OS actually does is it expands it to the full size on the first boot, regardless of whether it's dynamic or fixed. So you'll save time when you do the deployment, but it's going to expand to the full size on the disk anyway. We do support converting, though, so that you can do the time savings, but then expand it to fixed after it gets there. The key characteristic of that, though, is that you have to have enough space for the dynamic disk and the fixed disk, because we convert it both. We have to have both in place at the same time. All right, so I'm going to tell it not to convert. Then we have we need a number of pieces of information about the type of hardware or how to configure that hardware. So first is how you want to configure the management adapter on your machine. You can select a logical network if you want static addresses for the management adapter, or tell it you want to use DHCP. Then we have to know how to configure the disk in that machine. So we have a number of ways we can format the disk. We can format SMBR, or we can format it using the GPT format. And then the OS itself, how much space do you want to allocate for the OS? And then you can add additional partitions if you have a data partition. If you are actually going to use local storage, you can format the disk for local storage as well. And then I mentioned putting drivers in the library. How does VMM figure out which drivers to put into the VHD when it deploys it? Well, by default, we'll do a plug-and-play enumeration of the hardware when we boot into it for the first time, and then copy the drivers that match the plug-and-play IDs by default. If you know specifically which drivers you want to deploy, we can also have an option where you can tag the drivers in the library. You can apply tags to them, and then select which tags you want to use for copying over. So that way, if you know specifically, this driver needs to go in to the machine, you can tag it, and then it'll copy those drivers over. Next, of course, you have to customize the OS. This was a lot of the information I entered in manually. You have to join to a domain. So in this case, I'm going to do DC Manager Lab. You have to have a set of run as credentials. Again, a run as account is what contains a set of credentials. It's a container for credentials. You have to have a local admin password. And then there's all the other OS customization information. One other key section here is the answer file. So we use the unattend process for customizing the operating system along the way. And part of that is we create an answer file that gets run by the sysprep utility within Windows. If you want to do more than what we customize, you have the option of adding a supplemental answer file along the way, and we'll merge the two together. So if I do browse, I have one here, for example, that enables RDP on the machines automatically. And I'm going to select yes, say that I want to populate. And so now it's going to merge these two files together, and then when I do the deployment, it's going to take the steps for doing whatever is configured in here. If you go onto TechNet and look up unattend configuration, you can find out what can be contained in these XML files. And then we have our standard placement configuration. Where do you want to put the VMs by default? One of the other key things that we do is when we boot from VHD, the C drive within the OS is actually the VHD itself. The physical drive becomes your D drive. You don't want to put, if you're using local storage, you don't want to put the VHD within a VHD. So what we do is we mark that VHD automatically as not available for placement. We'll end up putting, if you are using local storage, putting the VMs on the physical drive automatically. So we can leave this as the default. And that's it. We've created a new host profile, and now we can use that for deploying additional machines. So I'm going to switch back over to my slides and talk a little bit more about the background about about what are some of the other customization steps, what is the actual process that's going on in this job along the way. So we've already kicked off the bare metal deployments, and I'm going to show you some of these customizations that we can do. So I mentioned that you have to be able to boot into you have to do a PXE boot so that we can get a boot image onto that machine that will run our agent. Now, in order to do that, we have to be able to deploy a WinPE image into the PXE server so that it can copy it out there when that machine boots. So when you add the PXE server, this is essentially what happens. Beforehand, first, when you set up your VMM server, you have to install Wake. It's a prerequisite for VMM. Wake contains the standard WinPE image that Windows has available. It has no customizations, just your default WinPE image. The next step is you have to enable the WDS role on Windows Server 2008 R2 or R2 SP1. The WDS role is what provides the PXE server that you can add then to VMM. You have to have a DHCP server along the way. PXE and DHCP go hand in hand. And then once you have all that, you can add the WDS server to VMM using the Add Resources wizard through VMM. When you do that, what we actually do is we install a provider into WDS. That provider sits first in the provider order and basically intercepts all of the PXE requests that come into that machine. It checks to see if that PXE request matches the SM BIOS GUID that we discovered, the one that I showed you earlier on, and then we will authorize the deployment or not based on that. We then also, as part of that process, we install the VMM agent. We have to have an agent on that WDS server as well. We create a folder for containing our files. And then we publish a WinPE image. So I mentioned that you have to enable the WDS role, but you don't actually have to configure any. If you're familiar with WDS, normally you would configure, copy an OS image out there. You don't need to do that. We'll do that when you add that machine to VMM. When we do copy that WinPE image out there, though, we do a number of things to it. We will inject our agent into that machine, and we'll also inject a certificate so that we know that that PXE request that is being asked of the VMM server is actually a valid one. And then that's the process. So once you've added that WDS server as a PXE server to VMM, then it's available for use. Now, if you have machines that are 2 years old or were available at the time that Windows Server 2008 R2 came out, WinPE will generally have drivers in it that will work for the network adapters and storage. But if you have newer machines that have come out in the last 2 years, they may have newer network adapters or newer storage types. And those newer adapters and storage types will need additional drivers to get injected into the WinPE image. In order to do that, you have to use a script to inject into the WinPE image in advance before we copy it out to the WDS server. This script is an example of how you would do that. Use the standard tools. DISM is the standard tool that's used to customize a WinPE image. And this script, which you can copy from the slide deck, basically will take a default WinPE image, a .wim file, and a driver tag. This driver tag will then be used to go out and query the VMM library, find all the drivers that match it, and then copy those. You can see the get SC driver package. It'll find the path, and then it'll use DISM to copy those directly into the WinPE image. And then the final step is to publish that Windows PE image out to your WDS server. It's important that you do it in this way because part of publishing is putting our agent in there, as I mentioned. And if you copy the WIM directly or customize the WIM that's on the WDS server itself, you'll lose the agent and certificate that we have on there. So it's important that you do it through the publish command. All right, so these are the steps that I mentioned that it's going through behind the scenes of that machine that's being deployed. So we start off with the bare metal server. So what is this new host job doing behind the scenes? So the first thing that happens is, now that we've discovered the machine, we can tell the same VMC that we use for discovery to reboot the machine. Now you have to have the machine configured to boot from PXE so that it will actually go out and talk to the WDS server. When it talks to the WDS server, it's going to go and ask the VMM server, is this machine authorized? Does this SMBIOS GUID that I'm getting from the Pixie request match the one that you discovered earlier? Now, one thing that's important about this, if it doesn't match, we'll send that, we'll basically not authorize it to WDS, and WDS will pass that request on to the next provider in its list. That next provider could be SCCM, so we'll coexist with SCCM if you're using that for doing other types of deployments, or some other third-party user of WDS. So we will coexist because you can generally only have a small number of WDS servers in your network. If we do authorize the Pixie boot, then we actually copy that WinPE image, or we download it to the machine and boot directly into that image from memory. Once we have the WinPE image there, our agent starts running, and it can now start to do things to that bare metal machine. The first thing that it can do is it can run these generic commands. We call them GCEs. These generic commands are essentially scripts that will run on the host. These scripts, these pre-deployment GCEs that happen on this step, are used to update the firmware to a consistent level. You can use them to also update your storage to a consistent level or create your RAID arrays if you're using local storage for RAID. Often when you deploy the OS to your local disk, you want to mirror those disks so that your OS has some protection. I'll show you this step how to create these in a minute. Next step, once we now have the, once we've run our GCEs, we've also configured the partitions and formatted the disk based on how the host profile has it configured. Now that we have a file system, we can actually copy that VHD to the machine and inject the drivers that match by the plug-and-play ID. And then we can boot into the machine for the first time. When we boot into the machine, the sysprep process automatically runs on the NO10 file that we've injected into it, and it goes, customizes, joins the domain, and gets the machine ready to go. And then the final step, once it's booted, we install the VMM agent and make sure that Hyper-V is enabled on that OS, so that it's now actually a standalone Hyper-V host. You can actually, if you're using standalone hosts, you can actually start deploying immediately onto this machine. But there's one other step that you'll generally want to do, and that's to actually do teaming of your network adapters. All right, so let's talk about these. Step 10 is running your post-install scripts for doing teaming. So I'll walk you through these GCEs for a few minutes. So I mentioned the pre-deployment GCEs. The purpose is to get your firmware in your machine and your storage to a consistent level. There are a number of steps. First, you have to get the utilities from your hardware vendor that are needed in order to configure the firmware. They're very specific to your vendor. Then we actually have to add these GCEs to the host profile. You do that through PowerShell. And then you can start the bare metal deployment process, and then our host profile will automatically run these GCEs as part of the process. So there are two ways you can actually get these utilities that you need to use onto the machine. You can either pre-bake them into your WinPE image, so you can copy them into the WinPE image using DISM. We call that using a local resource. And then you can execute using the script commandlets. First thing you do is you do new SC script command setting. This basically tells VMM how to run the command that you're going to run and what to do with the results. So you can say, check the output to see if it matches an expected return code. And if it doesn't match, then you can fail the job. So you'll know, if that command was successful. The other thing you can do, and then the next thing you do is you actually tell it which command to actually run. In this case, we're using a local path to configure the RAID array. You generally will need to first, just in case there's a RAID configuration already there, clean it out, and then you can tell it what kind of RAID to configure. So you have to go to the documentation of your hardware vendor to figure out how to set up these commands, because they're very specific, in this case, to Dell. The parameters are specific to the hardware vendor. The other option is you can actually put these utilities into what we call a custom resource in the VMM library. And a custom resource is really nothing more than a directory that you create on your library server with a .cr extension. This .cr extension basically tells VMM that this directory contains files that you're going to copy out as part of this script command that you're going to run. And then you specify farther down in here which library resource you want to use. So up here, the first command, you get the resource as the .cr directory. and then you specify it. And then as part of doing that, we'll actually copy these files into the WinPE image. So it's less customization that you have to do in your WinPE. This is the preferred route over using the local resource. You'll use the local resource generally if your hardware vendor won't support this method of using the custom resource. Now, the other opportunity you get to run GCEs is after deployment. This is where I mentioned you want to do this for doing NIC teaming. There are a number of other reasons why you'll want to do this for, if you do NIC teaming, if you want to set up iSCSI. Basically, any command that you want to run after your deployment, you can use these post-deployment GCE scripts. And basically, it's just a single command you run. It's invoke SC script command. You can actually do these from our UI as well, but you'll generally set up a script that you can drop in the library. And with that, I'm going to hand it off to Amit, who's actually going to go through and show you how to actually run this script that I just had up there. So go ahead, Amit.
Thank you, Greg. So like Greg was talking about the GCEs, and we are going to take a look at the post-deployment GCEs, which can run on a pre-provisioned bare metal machine. So what I'm going to do here is I have a machine which I've already pre-provisioned with the Hyper-V host as a Hyper-V host. And it has a few NIC cards on it. So I basically have, let me switch over to my monitor and let me show you the actual machine on which we have the cards here. So on this machine, which is a Dell machine, I basically have 4 HP NIC 360T PCI Express dual port gigabit server NIC cards. And what I'm going to do here is basically take these 4 cards and actually create a team by running the post-deployment GCEs. Now, if the other thing you look at here is I've also downloaded one of the executables that Intel ships for creating a team. And I'm just enumerating all my adapters here so that I know what indices these adapters actually represent. Now, I'll switch over back to my VMM server. And I'll open the PowerShell. And what I want to do here is just basically run the So the reason I'm actually running a start demo here is I don't want to mess it up by fat fingering. So just making sure that everything is scripted out there. And I'm going to walk through each of the commandlets when we run it out here. So before I actually execute this, let me go back to the host that we have here. So I go back to my Fabrics view, go up into the servers. And this is a machine that I was actually showing on which we're going to be executing this. So let's open the properties of this host first. I get into my hardware page. And if you look at it here, we show all the 4 or all the 6 network adapters that exist on that particular given host. And these, if you look at them right now, these are not teamed as of yet. So the 4 HP NIC cards that you actually see here are the ones that are going to get teamed. So go back to PowerShell, and let's start this demo. All right. So the first thing that I'm doing here is basically just importing my PowerShell module from VMM so that I can actually be able to run all my VMM commandlets from the PowerShell. The next one is just getting a connection to the VMM server so that I can execute the VM commandlets. This just gives me back the VM server object, which has a bunch of properties in terms of which VM server it connects to, who is the user, what kind of domain it is, and so on and so forth. This is the machine that I'm going to be executing my GCE on, so I just put it into a variable out here. The run as account that Greg was mentioning earlier, using which I'm actually going to be invoking these scripts on my Hyper-V host. So if you look at the comment out there, it says that this first commandlet is actually going to fail. And the reason why we put it out here was to actually show the error message and to show the clarity and the granularity that VMM shows whenever a commandlet fails, and the action that you can actually take by just looking at the error message from VMM's job view. Okay? So the issue here is that I'm passing an extra parameter into the actual executable that is already there on my host, and it's actually expected to fail. So let me run this and go back to my jobs view on VMM. We will go back to this. And if you look at this, this actually says that it's an invalid command usage. And the actual usage does not have any /k parameters. So as an administrator or a delegated administrator, you can, once you run your GCE, if anything fails, you can always come back to the jobs view and actually figure out why something would have failed. Let's go back to the PowerShell, and let's run another commandlet which is actually using a wrong adapter. So if you remember, switching back to the other host, if you remember, what we have here is we have 6 NIC cards out there on this machine, and there is no 7th or the 9th card. But the commandlet that I'm actually invoking, I'm trying to team the 7th and the 9th adapter. This is just another variation which I'm actually showing to say that the error messages that are returned by the executable themselves are going to be shown on VMM as is. Switching back to VMM server, executing the commandlet again, go back to the fail commandlet, and again, if you look at it here, the standard output error log says that the adapter 7 doesn't exist. All right, so enough of failing. Let me actually go ahead and make sure that the creation of the team actually works. So as Greg was mentioning earlier, what I'm doing here is just using a local resource. So this is the commandlet that I'm actually running, the invoke se script command. This is the host that I earlier fetched into my $VM host object. The executable already exists on that particular host. The command parameters are what the executable takes to actually create a team NIC. And these are my 4 adapters, 2, 3, 4, 5, which we saw in the indices earlier. These are the HP cards that I'm actually going to be creating. This is the name that I would be giving, and this is the team mode that I want to specify for these 4 NIC cards. I'm just using a default timeout of 60 seconds. The timeout here is configurable if you think that the executable could take more time. The timeout here is just a VMM job timeout, in which case, if it takes more, the VMM job will actually time out to make sure that you don't actually just have the job running all along. All right, so while this job runs, as Greg was mentioning earlier, the GCEs, or the post-deployment GCEs, are a very powerful tool in VMM. You can think of it of doing any provisioning or any configuration if you want on your host once they have been provisioned. One example is, let's say you want to install PowerPath if you have EMC hosts that connect to EMC actual storage. And since you cannot install them directly from VMM and you don't want to go outside and install it on the host, you can just invoke a script from VMM and actually do that. The other way is going ahead with Windows Server 2012 and the usage of storage spaces. You can actually go ahead and configure storage spaces by writing a custom PowerShell script and invoking it directly from PowerShell info, from the GCE. Now, if you look at this here, this script actually succeeded, and what we print out here is just an informational message, which says that it actually exited with the code 0, which is good for us. So let's go back to my Fabric view, so that we can go back and take a look at the properties of the host. So I click on the host, right-click here, go to the properties of the host, go back to my hardware. One thing I remembered here was, or I forgot rather, was that I haven't yet refreshed my host. So we created the NIC team out of band, but I still haven't yet refreshed my host. So let me just go back, click the host again, and actually refresh the host so that we pick up the latest NIC properties out there from the actual physical host. Now, while this happens, the other things that you can think of running a post-deployment GCE is if you want to do any iSCSI configurations. That's another investment that a lot of customers and partners have actually done, is they want to make sure that they can log in into every target on any of these nodes or any of these machines that they bring up. All right, now that my host has been refreshed, let's go back to the properties. Let's go to the hardware. And now if you see here, we have the team NIC created. Now if you notice, we actually pick up not 4, but 5 cards. So we consider all the 4 NIC cards as a single card. And we also go ahead and pick up this final NIC, the final team card. And now if you also see, since we know that the 4 cards can connect to the traffic or the network out there, we also automatically assign the logical network to this particular team NIC. All right, so let's move on to the next demo. As Greg was mentioning earlier, this session is basically, if you think, a flight from ground all the way into the cloud. And the first part of the journey that Greg walked you through was to get a bare metal machine all the way as a Hyper-V host. The next part of the journey is actually to make sure that if you have hosts which are provisioned, how do we create a cluster? And if you think of a cloud, it consists of three things: compute, storage, network. So let's look at the compute first. So what I have here is I already have two hosts that have been pre-provisioned. I'm going to drag drop them into my host group so that I can create a cluster out here. All right, so my compute is ready now. What about storage? So let's go down and look at the storage. With VMM 2012, what we have done is we actually now can manage storage from VMM. What we use is we use industry standard SMIS providers to actually talk to the external storage, the array, be able to create a LUN, be able to classify the pools, and we can always create LUNs or storage on the fly. So what I'm going to do here, or what we have already done, is I've added a provider. This is a NetApp provider. So we worked with a lot of partners like NetApps and EMCs of the industry to make sure that they actually help us implementing these providers. So we've added a NetApp provider, and I'm already managing an FAS 2020 array which is being managed with this particular provider. We have a classification and pool. What I've done, or what we have already pre-provisioned, is we have a gold classification here. This is the pool that we manage. In NetApp terms, a pool here refers to an aggregate. And if you look at the LUNs here, there are already 3 storage logical units that are there. Now, I'll go ahead and create 2 brand new LUNs for the cluster that we want to create at this point. So I am on the aggregate. I go to create, and I want to create a new logical unit. Now, the first logical unit that I want to create, I'm going to call it an HV cluster B. And what I want to do here is this is going to be, since I'm going to create a cluster, I'll use this LUN as a CSV. So let me just give it some more storage. So I'm going to create something with 40 gigs. If you look at this, we created it. We are going to create it from the storage pool that is already being managed by VMM. The next thing is, for a cluster, I also need a quorum or a witness disk. So I'm going to go ahead and create one more disk out here. Just calling it W so that we know that it's a witness disk. And I'm going to leave it as size 1 gig because it doesn't really matter. It just has this, which is used on the cluster to act as a witness disk. All right, so now once these LUNs have been created, the next process is to actually allocate the LUNs or the storage to the host group on which my cluster is actually going to get created. So from here itself, I can actually go ahead into allocate capacity, or I can open the host or the host group properties page and do the same thing. So let's click on allocate capacity. If you look at this, this is the host group. So I'm going to select the host group into which I drag my hosts. I'm going to go into allocate logical units. And if you see here, these are the 2 LUNs that we just created, and I'm going to allocate it to the host group so that at the time when I want to create a cluster, I can use these particular logical units. So let's add it into my allocated group. And all this is doing here is just making sure that this is just a simple DB operation where we just make sure that these particular storage is allocated to the host group out here. All right, so I go back now into my host group. And here, if you look at it, there is a create Hyper-V cluster. So next thing I'm going to do is actually going to be creating a cluster right here with the storage, with the compute that we've already used. So the cluster name, let me provide a cluster name here. We're going to use an existing runners account. The runners account is used to get access to the individual hosts and be able to talk to the cluster service so that I can join them to the domain as well. So I'm going to use the domain account. The next thing is it asks me to select the nodes with which I want to actually do or create a cluster. So these are the 2 nodes which are available right now, and I'm going to add both of them here. As the nodes that I want to cluster. Now, one thing that I'm going to do here is going to skip cluster validation tests. This is not recommended. The only reason why I'm doing it here is so that I can quickly go through and show you the actual cluster which gets created. The reason why skipping the test is not recommended is because clustering team or Windows cluster actually recommends that you make sure that all the storage, all the networking, all the hosts actually run through the detailed tests that have been created by them so that you know whether your cluster is actually going to be able to host your workloads. But here I already know everything is good, so I'm just going to skip it for time being. On the next page, it asks me to enter a cluster IP address. One option is you can actually select a static IP pool, or you can just enter the IP address. Since we have already provisioned all these in the DNS, I'm just going to enter my IP address and then go ahead. All right, so that's the IP address. Now, if you look at this, these were the two logical units that we had created, allocated to the host group that show up here. Now, if you notice, one of the disks has already been selected as a witness disk. So we already select any disk which is the lowest in size or in storage and make it as a witness disk. Now, I'm going to select the other disk also. I'm going to do a quick format, and I'm also going to convert it into a CSV. So if you notice the simplicity and the ease here, you can actually take a storage logical unit, create it on the fly, and also make it a CSV directly from VMM. The other option that we have here is to actually do a force format. So if you already have a LUN which is already allocated to the host, and let's say you already have a file system on it, you can actually force a formatting here. So let's go ahead and create this. The third thing that I was talking about in terms of Fabric or cloud was the network. And what we have done here is we take a look at all the NIC cards on all the nodes that are going to be a part of the cluster. We look at the logical networks that these particular network adapters are connected to, and we show you the common logical network out here. So I'm going to select this logical network, and I'm going to create a name for the virtual switch that gets created on the host. If you remember in VMM 2008 R2, we require that if you have a VM which is highly available, it should be connected to a highly available virtual network as well. And that's the reason why we allow you to create a highly available virtual network right here during the cluster creation wizard. All right, so this is my virtual network name. And because I have only one NIC, I'm just going to allow host access to this particular machine. All right, that's it. All I needed was pick my nodes, specify the IP, assign the storage, select it if I want it to be a CSV, create the virtual network. And then all I need to do is just kick it off, go back and relax, and my cluster would be created in less than 3 minutes. Right now, I'll hand it over to Greg, who is going to walk you through the cloud creation, where we can go ahead and use the cluster that we created here and assign it to the cloud, and also through the user role and delegation.
All right, thanks, Amit. All right, so let's just go back to our first slide at the beginning and show you where we are in the process. So you can see we've started with our diverse infrastructure. We've created a logical and standard layer now on top of our hardware with the OS and with Hyper-V on top and a cluster. But now the next step is creating the cloud so that we can actually delegate that out to our users. So that's the next step. We've done 0 to cluster. Now we're going to do cluster to cloud. And then for that, I'm going to switch back over. And then the final thing we're going to do also, we will deploy a service to show you that it is a real job that is running. Okay. Okay, so let me switch back over. All right. So here's the fabric where Amit created the cluster. And we're going to go now and we're going to create a cloud. And we do that through our VMs and services section in our UI. So you can see we have a number of clouds created already in our environment. And I'm going to go up here and create a new one. So I'm going to do create cloud. I'm going to give it a name. This is TechEd Europe. This is what your self-service users will see as the name of the cloud. We generally recommend naming it based on your a level of service like gold, silver, bronze. You don't want to create one per user role generally. The cloud is a shared resource among all your users, and I'll show you how to share that among all of them. So here we can see it's showing the capacity that's available in this host group that we're creating. It is elastic though, so as new nodes get added, they will automatically become available. As new nodes get added to the host group, they'll become available as resources within that cloud. And then you can select which networks you want to make available to the users of your cloud. See CorpNet and DC Manager here. When you are using our service model, we have the ability to scale out a service. And in order to do that, we let you put a load balancer in front of that service. So as it scales out with additional nodes in the service, you can put a load balancer that has a single virtual IP address for your users to be able to access that service. So we have support for load balancers, and you can say which load balancer you want to make available to the cloud. In this case, we have an F5 big IP. And then you say which of the VIP profiles you want to make available for that load balancer. So you have a number of different, you can create a number of different ones for each of your different types of service. Here's the storage that Amit just talked about. And then you also have to allocate, or you can allocate, capacity within your library server. So you can have a path where you can let your users store VMs. You don't want them to just store VMs anywhere. You can say where they get to go. And you can also provide read-only library shares. So if you do give this user the ability to create their own templates, they'll need to have library resources available that they can use to create those templates from. So like your standard VHDs, you would put in a read-only library share, your golden images. And so they can use those library resources, but not actually modify them. The next thing I mentioned is that this cloud has the capacity of the host groups that you've scoped it to available. However, you may not want your cloud users to use all of those resources. So you have the ability, this is the first chance you have to limit what resources get used. So here you can set the capacity for the cloud. You can say unlimited by default, or you can choose to say you only want the user to be able to create 50 VMs, for example. No, not that many. 50. Try one more time. 50 VMs available in that cloud, so that now you can limit how many resources this cloud will consume within the host group. And then finally, we have the ability to create a capability profile. These capability profiles essentially define what types of VMs you can deploy into this cloud. We have them, by default, we create one for each of the different hypervisor platforms we create. So if you do have a Xen server or ESX hosts in your host group, you can say that the user can create VMs that will use the capabilities of those platforms. You can also create additional capability profiles to limit, even within the platform, what the user can do. So for example, you can create a Hyper-V HA capability profile that will say the users of this gold cloud can only create highly available VMs. You can create a non-HA capability profile if you want your users to not be able, so if you have a bronze level of service that isn't, they're not paying as much for, you can say they cannot create highly available VMs in the cloud. So we're just going to use the standard Hyper-V default, and I'm going to go ahead and finish. So now we have a cloud that's already available. It's immediately there, and the next thing we have to do is actually assign it to a user role. So we have this option here to say assign cloud. So I'm going to go ahead and select that. And so we can select an existing user role. There are a number that already exist, but I'm going to go ahead and create a new one to show you the process of going from scratch. So I'm going to say create user role and assign to this cloud. So first thing I'm going to do is I'm going to create a TechEd. This is going to be for my TechEd attendees in Europe. And I'm going to select what type of user role it is. We have a number of user roles in VMM 2012. Delegated administrator, if you have an administrator that only has administration capabilities of a subset of your environment, you can create one of those. Read-only administrator is a new user role in VMM 2012. Basically, our users told us they have a set of administrators they want to be able to see, to support the environment, but not actually be able to make changes. So we have that. And then self-service user. This is the same user role we had in 2008. R2, but now we've expanded on it here to give additional capabilities. So we're going to create a self-service user. You can then say what type of user which users you want to add to this user role. I'm going to add myself so I can actually log in. And then you say what scope this user role will have access to. I'm going to give them access to the TechEd Europe cloud that I just created. And now here's your next opportunity to limit the consumption of this cloud. You have two additional levels of essentially quotas that you can assign. You can do per role level, which is this top section. And that basically says all members of the TechEd attendee Europe user role can use as an aggregate, this many resources. So I can say that TechEd attendees can use only 20 of the VMs that are available in this cloud, of the 50 that I've made available in the cloud. So that way, if you have multiple user roles that share this cloud, no one user role can use the entire capacity. Now, in addition, if you don't want the users within that user role to use up all the capacity for that role, you can limit it even further and say that each user now can only create 2 VMs. So now each person in that user role can only create 2 out of the 20 that are available for the entire user role. So we give you a lot of granularity, a lot of opportunity to say how this cloud will get consumed. The next thing that you want to give them access to are resources. So I'm going to give them access to this template. This is the one that we're going to actually be deploying in a little bit. So this is a service template that we're going to deploy. And by giving them access to this service template, also give them access to the resources that are consumed by this template as well, or that are required by the template. You can also give them a specific user role location for this user role in the library for storing additional library resources. And then finally, there are a number of revocable actions you have available for the user role. You can say whether or not you want them to be able to author new templates, where they create checkpoints, do deployments. You have a great level of granularity. I'm going to give myself all actions, of course, because I'm in control right now. And then finally, you can give the user a set of credentials that you want to use. This is a way to delegate user credentials without actually giving the credentials to the user. So if you have a SQL server, for example, you don't want the user to have the SQL credentials, you can say you can use them, but you can't have them. So for example, I'm going to add this prod SSU credentials. Now this run as account now is available for the user to use. OK, so this is going to create this user role. And so I can immediately log into it now. I'm going to go open a new connection. You can see if we actually go down to settings, under user roles, you can see it's listed right here, TechEd Attendees Europe. So I can now actually log in as that user role. I'm going to open a new connection. And this is something else that's new in VMM 2012, is the ability to log in as a different user. We heard a lot of feedback from our customers, especially if you're an admin and you're not logged in on your desktop in the same domain as your VMM server. You want to be able to log in and it's a different domain, so you can do that now. So I'm going to log in as the same session. And then if you are a member of multiple user roles, it's going to ask you which user role you want to sign in as. I'm going to use my new one that I added myself to as my self-service user role. And so now it's going to start another copy of the administrator's console. And it's going to log me in as the self-service user. So you can see here now within this console, as a self-service user, I don't have visibility into my Fabric. There's no Fabric node down below. And you can see that there's no list of host groups here. I can really only see the cloud that I've been given access to. So what I'm going to do in this cloud to show that it really is real is I'm going to deploy a service. So I'm going to go down to the library. And you can also see the template that I gave myself access to as well. So here you can see only the resources that this user role has been given access to. So I'm going to select this service template, and I'm going to say configure deployment. Now, if you want to learn how to deploy a service template, there's a session right after this by Stephen Barron that will be going on if you want to learn how to create one of these from scratch. I'm just going to call this 2-tier, because this is a 2-tier service. I'm going to use my TechEd Europe cloud. And it's going to come up with the service deployment dialog. So now it's running our intelligent placement algorithm on the cloud. You can see it actually rated this cloud positively because we actually have resources available in this cloud. It gave you 5 stars. If you were a full administrator, you would actually be able to see the individual Hyper-V hosts or hosts in general that are available in the cloud. But as a self-service user, you don't get that level of visibility. And so finally, I'm going to go and do the deployment, show you that we really can deploy into this new cloud we just created. So now if we go down to our jobs, see that the service instance is being deployed. So this is now a live cloud. We've taken it literally from 0 to cluster to cloud, all during the course of this demo. All right, let me just switch back. I just want to show you one more thing. I want to prove to you that this is actually a live demo by going back to my new host deployment, which, as you'll see here, actually failed. This is how we know that it's live. And the reason is because the IP address that I specified was actually used once before. One thing we do with our IP address pools is we check the allocation of them to see if one's been allocated. And over the course of testing out this demo, I've been deploying the machine and removing it. Now, when we remove a VM and we delete it, we know that the VM is gone and that IP address has actually been, is no longer in use. But with a host, when you remove the host, we can't assume that because you have a physical machine out there that still could have this IP address, and we don't want to reassign it. So we actually do a check here to make sure that it's actually in use. And so what I can do is I can actually go to my Fabric and actually unassign that address and then restart the job. So if I go back to my logical network, properties, and I can see my inactive addresses. It's right here. So I can just click that, do release, and now this address is available for the pool to use one more time. So let's go down to my jobs, and I'm going to restart this job. So now we'll get a new job up top. See my service deployment is still running in there. Now it's actually doing the deployment. Now that's going to take a while. So if you want to actually see how it succeeded and what we can do with it after the fact, come to my networking session. It's a great way for me to encourage you to go to my networking session later today, and I'll show you actually the result of that deployment this afternoon. With that, let me switch back over to our slides. Okay, so I just showed you this demo of actually creating the cloud and consuming it. I showed you how to create the cloud, create the user role, assign the resources, and then actually deploy the service. So we actually went through the whole thing. But now that was in Windows System Center 2012. What are we doing in Service Pack 1 for OS deployment? We have Service Pack 1. We're working furiously on that to get that out to you. This is a little preview of what we have available. Now, of course, we want to be able to deploy Windows Server 2012, so we'll have that available in Service Pack 1. Today with System Center 2012, we do only support Windows Server 2008 R2 and Service Pack 1. We have this new capability called Deep Discovery that we're going to make available. One of the things about IPMI and Smash and these standard protocols is that they don't give us a lot of insight into what hardware is actually available in that computer that we're discovering. So what we do with Deep Discovery is we actually boot into WinPE, enumerate the hardware that's in that machine, and return it back to VMM Server before you then finish your deployment. So you can actually see what network adapters are available and what storage you have available in that machine before you do the deployment. I mentioned earlier that people don't like typing in MAC addresses. I don't like memorizing them. So using Deep Discovery, we'll know what hardware is available, so you can actually just select the adapter that you want to deploy to rather than type in a MAC address. And then finally, starting with our beta release, we're going to have some more advanced configurations available. We have a new concept. If you go to my networking session again later today, I'll plug that again one more time. You can learn how to deploy a logical switch or how to set up a logical switch. And then as part of our OS deployment, we'll let you actually set that up as part of the deployment process. Along with a logical switch, you can have a host virtual network adapter. That network adapter gives you basically additional access to the virtual switch as well. And then, as I mentioned, we'll let you select the network adapter and the storage that you have available on that hardware to make sure you map it all correctly. Just a few previews of what the UI will look like for some of that. So if you remember the discovery before, we still have the discovery panel. But what's new on this in the UI here is this option for deep discovery. By default, we'll go in and do the deep discovery in the wizard. You can still skip it and do the fast, IPMI or Smash-based discovery. But you have the option now of doing the deep discovery. And when you do the deep discovery, it'll run in the background of this panel. And then when it finishes, we'll now actually list the network adapters you have available, so you can actually select it and define it as your management adapter. And then you can go then further in and actually specify your addresses for that specific adapter. Since we're refreshing information in, we'll also populate if your machine supports CDN. We'll populate the field with the CDN, We'll return information about the data rate, and the state of that adapter to let you know if it's connected or not. So we give you a lot of information now, or we will give you a lot of information about how that adapter is configured. So with that, I encourage you to go to the rest of the System Center sessions that we have today. There are a number of them that are still occurring today on the last day of TechEd. I encourage you to go get the deep insight into some of these topics that we just touched the surface of. Storage in particular, networking. This MGT 315 is actually networking, not storage. So I encourage you to go to 315 if you want to learn about networking, and a number of other sessions available today. So with that, we'll be here for questions for the next 10 minutes or so. And I encourage you to enjoy the rest of your last day of TechEd. So thank you.